This is an explainer video covering the DHT11 programming. And so one thing I wanted to start with in Arduino was showing you that I have created a function called LabVIEW script. And this is 100% of my LabVIEW work for checking the serial available to know if things are on or off. And you might find this helpful just to pull this out. So if the serial available is contains bytes, so if there are bytes more than 0 available at the serial monitor, you reset your string. You use this char command to grab each byte one by one, and then you save it into string. And then you can read the string to see whether or not LabVIEW is writing on or off. And this is a nice way to allow LabVIEW to say, okay, ready to take data, turn it on, or turn it off because maybe I need to stop. So then I made these subroutines, sensor on and sensor off, and that would be specific to whatever I'm trying to do. So in this case, I'm measuring RH and temperature with my DHT11. And so that's what sensor on looks like. It looks like printing the RH value, a comma and a space, and then the temperature value. So if I come up here to some of these pieces, I'm putting my DHT11 on pin 7. And I'm going to use the built-in LED on 13 just to tell me if LabVIEW is reading the sensor or not. I've put a delay time that you might want to change. I have my LED on, LED off commands because I just grabbed a copy of my old code. And so then there is a library include statement at the top, and that allows me to declare my DHT11. And so when I look at import library, I've got DHT11 here. If yours, you notice it's not in the default files, so I'm going to add library, and then this is where I went to my documents folder, Arduino, libraries, and I put DHT there. Okay, and then I would open that, and I already had one, so it gave me an error, but that's okay. So it's creating a library, and if you recall, when you used, for example, your servo or your LCD screen, we had to declare hardware. In this case, we're declaring hardware as well. And that's because the DHT11 writes some serial data, which means it can write RH and temperature in the same analog output. And so we're going to use this library for some very simple commands to get the temperature in degrees C and RH. So nothing changed in setup. CHK is just reading the serial data, and it's DHT read 11. So there's my read. Temp C is coming out of a dot temperature function in the library, and RH is dot humidity. And then I run my LabVIEW script. If you review the requirements, you're going to want to change that to Fahrenheit. And so this is how, using the DHT library, I can grab the temperature, grab the humidity after I read the measurement off the pin. And then I want you, I want you to debug this piece. The tutorial posted from the open source site and some debugging on my side tells me that there's a delay needed here. I've played around. 1500 works all right. 1000 seems too fast. Try some numbers. See what happens if this is too small. I'd like that included as you're working on this because I don't want you to ever just take my word for it. Try out what happens if you made this delay, say, 150. What happens for your data in LabVIEW? So take a look. And so that's really all you need to know. So we're going to include a library, define pin 7 for our DHT11, write some variables here. This is a hardware variable, so it has the library as its type. And then we're going to read the serial data separate out temperature and humidity, and then however you want, you need to write that to or print it to the serial monitor. Print sends the variable or the string to the serial monitor. Print ln puts a new line in. And that's it. So that's the Arduino. So then let's take a look at what this looks like in LabVIEW. Take a look at how the LabVIEW runs. I don't have my sensor wired in, so my values won't make sense, but I do have a way to set my COM port here, a way to then enable my Arduino, and then in order to turn my sensor on and off, stop the program, and this is where I'll put my output for my sensors. So if I run this, I can still select my Arduino COM port before I hit the OK button to run the Arduino through LabVIEW, and I can turn my sensor on and off, and I can stop my sensors or stop my whole program. You should see updates here when there's actual values to read. And so the steps here look like opening the serial monitor. We have checking to see if the sensor is intended to be on or off. That's kind of an extra piece. You could absolutely, skip that step in a lab file. That would be fine. But the piece we're going to look at today is how do I check to see if there are bytes of the port, how do I read those bytes, and then how do I turn the string that I'm reading into values. So that's what we're going to look at. So instrument IO in Visa, that's where I can find most of this work. Let's see, is configure here? I might have to go somewhere else to find configure. So we've got close, we've got write and read. So I can configure my port, right? So I find it with my search function. Now, there are two commands that I'd like to look at with you that we haven't used before, and one is a Visa property node. And you can find that on Visa Advanced or just type it into your search box. So let me put a comment here so we know what these do. This is configure. That W tells me this is write, and that R tells me this is read. This is a Visa property node, and this is close my Visa serial communication. So my property nodes, there are many of these, and the property node I want to grab is the number of bytes available at the serial port. So I'm going to grab that piece of data because as I open my serial communication, actually I'm going to take that out, because we might not use write in this particular lab. I'd open my serial monitor or configure it, and then I'm going to check how many bytes there are. And if there are bytes of information available at the COM port, I want to read them. But if there aren't values available, I don't want to do a read step. And so that's where this is going to go inside a case structure, where I compare the number of bytes at my property node, at my COM port to 0. And if it is greater than 0, then I'm going to do a read step. And if it's not greater than 0, I'm going to run my loop again. So if I grab a case structure, my condition can be the output of this. I'm automatically comparing the number of bytes at the COM port to 0, and if it's greater than 0, this will be true, and I will read, and if it's not greater than 0, it's false, and all I'll do is pass the COM port reference through. And if it's true, I'm going to do this read step, and I will also make some sense out of the data. So how do we then make sense of our data? What comes out is a string, and that string is going to have however you put it in your Arduino code. So in mine, it's the RH value, a comma, and the temperature value. And so now I need to change that into 2 numbers. So I'm going to come over here to my functions, and it's on my string palette actually. So we'll just take a look. String, spreadsheet string to array. And so this will take my string and turn it into an array of numbers. And there are a few steps to that. My first step is to put my string into this tool. My second step is to give it a format string. And my third step is to tell it the delimiter between values. And so you can go to detailed help here. And you can see that the delimiter might be a tab, it might be a comma. We used a comma. The format string uses traditional C format indicators. We have %D and %F for numbers. D is integer, F is floating point. And so I'm going to, on this, add a constant for my comma, and that's my delimiter. And my format string constant will be %F so that I store some of the floating point information. I'll deal with the number of decimal points later. And then on my front panel, I can grab a graph, specifically a waveform chart on that graph palette, and I can update this only when there's information to be read. So my right step isn't done. I'm going to go ahead and delete that here so that I can run this and show you what it looks like. So all I've done here is put things into a flat sequence. I actually added a frame because what I want to add is a weight here. And the way you find errors, let me just walk you through my own debug process there. So I had a run error, my broken arrow. I read the arrow list. I have a unwired or bad terminal, show the error, it highlights, and so I'm going to grab my bytes at port and plug that into the byte count. My context help went away. So here I can see the byte count, right? That's one of the reasons why we're checking the bytes at the port. So it knows how much information it's going to read. So now I can run, and of course, because I'm doing this for a video, I forgot the last piece here. So Visa resource name, I'm going to create a control so that I can grab that. And here I'm going to just create a constant because that one's pretty standard, and run again. And so that should be it's only grabbing a single data point, but you can see here, right, at least it's getting data from LabVIEW. The frame here where it does the data collection needs to be inside a while loop. And this is the nature of making a video real time here. And now we can see it's noise, right? I don't have a sensor plugged in, but I can see my transmitter blip every time it's sending data to LabVIEW. And I can see my LabVIEW chart updating because there is data available at the port. This is running as fast as it can, but my Arduino is only sending data at a particular interval, and so that's how often it will be updated. I hit the stop button and it goes away. So this isn't complete. This doesn't meet all of the requirements, but it should get you started on writing values using Arduino to the serial monitor, and then using that same serial monitor in LabVIEW to read values into a chart.